Alright, so today, guys, we are gonna be using your fundamental trig identities. Now, I asked you to take out your unit circle, and on the back of your unit circle was this, okay? What these are, guys, are something that we've already known. So we've already looked at these before. We already know that sine is the reciprocal of cosecant, right? And we already know that cosine is the reciprocal of secant. We already know that tangent is the reciprocal of cotangent. We already know that tangent is sine over cosine. Therefore, cotangent is cosine over sine. The other ones we're going to use today, later on, are the Pythagorean identities. They're called Pythagorean identities. Why? What do you notice? Because they have a what? A squared. So it's like, here's basically, guys, these are rules. These are rules. So like earlier, Madalena, you were saying, yeah, but when I see the symbol 4, I know that it equals 4 things, right? For something. I don't know. It could be 4 fingers, $4, whatever. But I know that I have an association with that, correct? So these are rules as well. These are rules. If you ever have sine squared plus cosine squared, it's equal to 1. I'm giving you these rules, okay? I'm giving you these associations. And so we're going to have to basically understand that. What you basically need to, these are the ones that you have right now with you. What you have to fundamentally understand is this. What does equal mean? What does it mean to be equal? It means they're the same. Right? It means they're the same. Which means that they are interchangeable. What do I mean by interchangeable? What does that mean? Replace. I can replace them. So, like, if I said the sentence, there's a boy in my class. The word boy I can replace with Omar, and it means the exact same thing, correct? Right? So they're interchangeable. So you have to understand, anywhere I have a tangent, I can replace it with sine over cosine. Or vice versa. Anywhere I have a sine over cosine, I can replace it with a tangent. Do you understand that? Okay? They're interchangeable. Why would I want to do that? Because today we're going to try and simplify. Simplify means to do what? Break it down into the simplest terms, right? Break it down into the simplest terms. Sometimes I have something complex that looks like this, and I can just substitute, interchange it with just a tangent, right? Or sometimes I have something complex like this, sine squared plus cosine squared, and because they're equal, I can just replace it with a what? A 1. Does everybody see what we're kind of have to do today? All right, so here we go. There's no like, oh, here's the way you do this all the time. There's no formula for this kind of stuff, okay? So you just kind of have to do it. Hopefully you see the things. You have your rules. You're just going to replace, and hopefully you get to the right part, okay? So here is our goal. Here is our goal. It's very important to understand our goal. Our goal is to simplify the expression to a single term or number using your identities and just regular algebra, okay? Just like in the warm-up, how we use just regular arithmetic, essentially, right? It was just fractions. And I use the rules of arithmetic to simplify circles and squares and triangles and diamonds. Okay? So, here we go. I have cosine of x times tangent of x. Okay? And right above our goal, I gave you a tip. And it's very important to write this tip down or remember it. The tip is this. Try to write things in terms of sine or cosine when possible. Try to write things in terms of sine and cosine when possible. Sine and cosine, guys, are our most basic functions. So if I can write them in terms of sine and cosine, that's where I want to go. Okay? Okay, here we go. So here's what I have. I have cosine of x times tangent of x. So now, my tip was to write things in terms of sine and cosine. Is there something here? First of all, cosine is already cosine, agreed? But tangent. Can I replace tangent with something in terms of sine and cosine? It's sine over cosine, agreed? So does everybody see that this is really cosine of x times sine over cosine? Literally the same thing, correct? Why does that help? look what happens. I have a cosine. This is technically over 1, agreed? I have a cosine on top, and I have a cosine on bottom, so guess what's going to happen? They're going to cancel, and what am I left with? Just sine. That's it. Okay, so what did I do first? What was the first thing I did? I replaced my tangent with what? The sine over cosine. Where did I get that from? How do I know that that's true? From your identities, from your rules, right? So tangent is sine over cosine. So this and this mean the exact same thing, right? Why would I do that? Because when I did that, if I have a cosine on both top and bottom, because technically these are just fractions, are they not? They have to follow the rules for fractions, right? The rule for fraction is if you have the same thing on top and bottom, what happens to it? It cancels. So when your cosine goes away, I'm just left with sine. That's it. That's all we're doing. Does everybody see how this is going to work? All right, let's try another one. Let's try another one. Okay? Well, you are doing math. The math is, in this case, the concept of fractions, right? There's just no numbers here. You're not going to tell me x is equal to 3 or something like this today. I'm giving you fractions. I'm giving you identities that you're going to be able to replace, okay? This is very, very helpful, like in calculus. We're using this right now, as a matter of fact, because I have very complex expressions or equations, and they start off very complex, but as I remember my rules, as I remember my identities, I can make them simpler and then do the math. You see what I'm saying? Okay? So, here we go. I have cotangent of x over cosecant of x. I have cotangent of x over cosecant of x, okay? Neither one of these is in sine and cosine, but can I make them? Cotangent is what? Is cosine over sine. What about cosecant? It's what? It is 1 over sine. Does anybody notice anything? I have what? A fraction over a fraction. Just like the warm-up. What do I do when I have a fraction over a fraction? So, what happens to the top one? Nothing. It stays the same. So I'm going to have cosine of x over sine of x, but instead of dividing, I'm going to multiply this by what? Sine over 1. Now do you notice what's going to happen? The sine's going to cancel out, and I'm just going to be left with isn't this simpler than this? And you have to basically, what I'm trying to get you to understand here, guys, is these are the same thing. Okay? These are the same thing. Simplifying does not change your expression. Right? Simplifying just uses rules, uses equalities to make it look simpler. So if I gave you this, it's really just this once you apply regular math rules. We got it? All right. Let's see if we can make it a little bit more complicated. Same rules always apply. Same rules always apply. Okay. I have secant of x times sine over tangent. Okay. I have secant of x over sine over tangent. And remember, my tip was try and make things in terms of sine and cosine. Okay. Can I change secant to what? So I have 1 over cosine times, am I going to change sine? It's already sine, so leave it. So I'm going to have sine over tangent is sine over cosine. So now students get kind of weirded out by this because they're like, there's only one thing up top, right? So it's not like the last one where it was a fraction over a fraction, right? Yeah, just put it over 1. This is just over 1. So now it's just a fraction over a fraction. Okay? So what we're going to do now is concentrate on only this for 1 second. Concentrate only on this for 1 second. So does everybody see that I have here sine of x over 1. And then when I multiply it, it'll be what? Instead of sine over cosine, it'll be what? Cosine over sine. And what's actually going to happen there? The sine will cancel, and I'll be left with what? Just cosine, correct? So all this simplifies to just cosine. And then I still have my 1 over cosine from up here, and notice what's going to happen here. So this is technically over what? And what's going to happen? So what happens when everything cancels? No. It's equal to 1. It's equal to 1. Be very careful. When you have fractions, it does not go to 0. It's just equal to 1. So basically, all of this was just equal to 1. Okay? All of that was just equal to 1. Does everybody see how this is going to work? You sure? Think you can handle it? Okay. Let's make it harder. So here we go. I have sine of x cosine squared minus sine. Sine of x cosine squared minus sine. So this one's kind of weird because everything is already in sine and cosine, right? So how can I even how can I even simplify this if everything is in terms of sine and cosine already? Well, you still can. Okay? I need y'all to pay very close. Look at this very simply. Okay? Because obviously I can't change anything. I can't change this to sine over cosine or this to cosine or whatever, right? Some students are like, well, can I change them to cosecants or secants? Because those are the same, right? Yeah, you can, but it's not going to do you any good. Okay? Do you notice, how many terms do I have here? There's only 2. There's 1 here. This is all 1. And this is another one. Terms are broken up by what, by the way? Terms are broken up by either addition or subtraction. Why? How would you can't just make it go away. Yeah, but this is sine times cosine. So this is a buddy. They're together. They're boyfriend and girlfriend. You can't just break them up like that. Well, there's a multiplication, right? There's always a multiplication there. It's just like me saying 2x, right? There's not a dot there, but I understand that means 2 times x. Same concept, right? So guys, look at these 2 terms. Do they have something in common? Do they both have something? A what? They both have a sign. They both have a sign, right? So, go back to algebra. If 2 terms have the same thing, what can I do with that? Factor it out, right? Like imagine this. Imagine if I had 2x squared minus 4. What do they both have in common? A 2. So I can take out a 2, and I'll be left with what? X squared minus 2. I'm doing the same thing here, but with sines and cosines. So notice they both have a what? So I'm going to take out a sign. If I do that, what's left? Cosine squared, and this is where I think most people will make their mistakes, minus 1. I didn't take out a negative, right? So don't forget that there still has to be something there. How do I know I did it right? If I were to distribute this back, wouldn't I end up with this? Right? This is what I'll always get from students. They'll say, well, look, if I take away the sign from this one's left with cosine, but this one has nothing. So then there's nothing here. I'm like, well, wait a minute. If you distribute it back, then you're not equaling the top line. Does that make sense? Right? Because you'd be missing the minus sign. Is everybody with me now? Okay, so it's getting a little simpler. Instead of 2 signs, now we have just 1 sign. Right? Let's see if we can simplify this even more. Do me a favor and go to your Pythagorean identities. And now the reason I'm going to my Pythagorean is because guess what? This is squared, and Pythagoreans are the only ones that have the squareds, right? You have one that says this: sine squared plus cosine squared equals to 1. And I'm going to put an x. Yours has a u. It doesn't matter, right? It's just a variable. So it can be sine squared of cookie plus cosine squared of cookie equals 1. Does not matter. It's just a letter. So now, here's the thing that everybody always forgets, guys. Just because I give you this rule doesn't mean that you're stuck with this rule. Okay? I'm going to manipulate this thing a little bit. Okay? Say I gave you this. Everybody understands this, correct? That 2 plus 3 equals 5? Right? Everybody agrees to that? I hope so. Okay? So now, 2 plus 3 equals 5. Give me another fact. Just out of this statement, give me another fact. That's a good one. He said 5 minus 3 equals 2. That's very good, right? Does everybody still agree with that? Is there another fact from this line you can give me? Five minus 2 is equal to what? 3. Is everybody... That's reasonable to agree with, right? Guys, I can do the same thing here. I can do the same thing here. I know that sine squared plus cosine squared is equal to 1. So then it's also true that sine squared is equal to 1 minus cosine. Right? And it's also true that cosine squared is equal to 1 minus sine. Agreed? Yes, no, maybe so? You understand where I'm getting these from? Okay, so now why does that help me? Why does that help me? Look what I have here. I have a cosine squared. I know that cosine squared is equal to what? 1 minus sine squared. So check out what I'm going to do. I have a sine of x. And instead of saying cosine squared, I'm going to say 1 minus sine squared x. But then, of course, I still have my minus 1. You guys notice anything? I have a 1 minus 1. That's actually going to go away. So what am I left with? Sine times negative sine squared. What's sine times negative sine squared? Negative sine cubed. It's just an exponent, right? Follows the same rules as exponents. X times x squared would become x cubed. So negative sine cubed x. Fun, right? So how did I change it? Because look, from this one rule, I got these two other rules, right? And these are true too. Just like this one's true, these have to be true too. So what I did was I took my cosine squared and said, look, that's 1 minus sine squared. So I replaced it, just because they're interchangeable. That's what we said earlier. They're interchangeable. So cosine squared became 1 minus sine squared. But then I still have a minus 1, but the 1 minus 1 goes away. So I was just left with a minus sine squared, right? So here, I was just left with this. Okay? So then, just multiply. Sine positive times a negative is a negative. Sine times sine squared becomes sine cubed. I would write these down on your trig identities paper. Okay? Because these are now facts just the same as the others. These are now facts just the same as the others. Okay? So, that being said, you see your other two Pythagorean identities? Like, what's the next one you have there? Tangent squared plus 1 equals what? Secant squared. Can you give me something else out of that one? So what could you do with that 1, maybe? Put it on the other side. So then give me another fact. Tangent squared is equal to Not 1 minus, it would actually be secant minus 1. Okay? So I would write that one. You see what I'm doing, right? I know that these are the rules that you have on the paper, but you can also create your own. That's where you're not limited to what's given here. Okay? Okay, a couple more examples. The thing about this, guys, is this. There's no way to just be good at this. You just have to practice. Okay? And there's no rule. There's no, because students are always like, well, how did I know to do that? You don't know. Just try it. See if it helps. If it doesn't, try something else. Okay? Let's try this one. This one's a fun one. I have sine of x plus cotangent cosine. Sine of x plus cotangent cosine. There's one thing that's standing out to me right now, which is the what? The cotangent, because why? It's not in terms of sine and cosine. So let's change that one first, right? So sine of x plus, what is cotangent? Cosine over sine, and then I still have a times cosine. Are my cosines going to cancel here? They're not. It's not going to cancel. Why not? It's not. They're both on top. So what happens if they're both on top? You actually multiply them. So does everybody see what I really have here is sine of x plus cosine squared over sine. And sometimes I forget to write x, guys. It doesn't really matter. I mean, you can write it. You don't have to. Is everybody good with this so far? Okay. Now, okay, so now I can cross out what? Can I? Can I cross out the signs? No. Why not? They are adding. They are not multiplying. They only cancel when you're multiplying. When you're adding, you got to do something different. What? Good. Notice this. These are technically two fractions that want to add. And just like our warm-up, where I had a triangle and a circle, two totally different things, how do I make them the same? You got to give it what it's missing. So this one's kind of easier because here, what does this one need to be? Sine. And then, do I have to really multiply this by 1? No, it's not going to change anything. So I need to multiply this side by sine over sine. Remember, it has to be to both. It has to be to both. You can't just throw in something because then you're changing it. But here, if I multiply this by 1, am I changing it? No. So then, guys, what do you end up with? What happens when you actually multiply? So you have sine squared of x over sine plus cosine squared of x over sine. And because they actually have the common denominator, I can actually add them. So does everybody see what I have here is sine squared plus cosine squared over sine. Agreed? Now that still looks pretty complicated to me. That we're trying to simplify. Do you guys notice anything? Your Pythagorean identity says that sine squared plus cosine squared is equal to what? So this is really 1 over sine, and even that can be simplified even more because 1 over sine is what? Cosecant. See how that works? Are there any numbers here? No. Are there symbols? Yeah. We call them words. We call them trig functions. But they work the same. Why? Because they're fractions. Because they're multiplying. Because they're adding. And all of those things have rules. Does everybody understand your warm-up now? Right? You understand the reason for your warm-up, right? Because that's what I'm trying to show you. That all of that stuff still has rules. So follow those rules and you can basically, I can replace these with anything, right? We okay? You sure? I think Why don't you try this one? I'm gonna see if you can try this one. This one's a tough one. I want to see where your brain's at. All right, so for this one, this came down to, guys, what does squared really mean? Times itself. That never has gone away, right? Squared always means times itself. Even if I had something as simple as x plus 2 squared, that does not distribute the square. You actually multiply x plus 2 times x plus 2. And how do you do something like this? You FOIL, right? Or window, whichever I don't really care which one you use. But so then that does not change over here. So what I'm asking you to do here is this. I'm asking you to multiply it times itself. And in this case, we're going to have to FOIL. All right? How do you FOIL? You do the first thing times everything in the back, and then you do the second thing times everything in the back. And if there was a third thing, you do that times everything in the back, right? So that's what we're going to do. So ignore this for 1 second. What's sine times sine? Sine squared. What's sine times cosine? Yeah, you can't simplify that, so it's literally just sine times cosine. Agreed? So sine cosine. Everybody good with that? Now let's do the cosine. What's cosine times sine? Cosine times sine, right? Cosine times sine. And finally, what's cosine times cosine? Cosine squared. Now, guys, normally when you FOIL, what do you do next? Combine like terms, if you can. Are there like terms here? Yes. What are these two things doing? Multiplying, which means order does not matter, because 2 times 3 is the same thing as 3 times 2. So order doesn't matter. I know we wrote them differently, but what I need you to understand is this, or this, is the same thing as this. Does that make it better? Right? So now, is it more apparent that these two are the same thing? So then what do I do with them? I add them. I'm just combining. So how many were there here? 1. How many were there here? 1. So guess what you have? 2 sine cosine. Does that make sense? And then, of course, those other things, just like before, they just drop, right? What's up? Yeah. These two? Like these two, square them? Because what am I'm combining like terms, right? I'm combining like terms. So you're saying, why doesn't this combine with this? Because when does something become squared? When it's multiplying. These are not multiplying right now. They are adding. You see the difference? So it's like one of these plus another one of these just becomes 2 of these. Does that make sense? Okay? And then these other 2 things dropped. But then Cassie noticed something. She said, hey, my Pythagorean identity said that sine squared plus cosine squared is equal to what? 1. So those 2 things became 1, and then I'm left with a plus 2 sine of x cosine of x. That's as simple as that one gets. Okay? Because you remember, the only thing you can do with sine and cosine at this point is change it to secant and cosecant, but then that doesn't help you anyway. You know what I mean? So this is as simple as it gets. Does everybody kind of understand this lesson, right? I mean, I understand, trust me. I understand it's way complex because it's very conceptual. It's not like, sir, I want to know what x is. X is 2 or x is 3, right? How do I know? It's like, at this point, it's kind of like, you don't really know. Students are like, well, how do I know when to stop? And I'm like, you don't really know. You just, can there be something else to be done? Yeah. Was it going to help you if you do it? No? So then you're done. You know what I'm saying? Because like here, I can change this to 1 over cosecant, or I'm sorry, yeah, to 1 over cosecant, and this one to 1 over secant, but that's not going to make it, I'm just going to have different words. You know what I mean? It's not going to cancel out or anything like that. So you're done. Okay? You have the rules. You have the manipulations of the rules. You can, but everything follows the basic rule. The stuff you learned in elementary still applies. Okay? Alright, so you are going to get a worksheet, and I'm giving you the